This video will be showing you how to name simple organic molecules and will include some examples to help apply the concept. As I'm sure you are aware, the type of carbon-carbon bonds that are present in a molecule describe the type of organic molecule we have. The simplest alkane contains only single bonds between carbons. When at least one double bond is present in the carbon skeleton, this is an alkene. Alkenes involving triple bonds are called alkynes. The endings of these words, ane, ene, and ine, is used to help identify what kind of carbon chain is present. We will start with a simple example. You can see here that I've used a line structure representation of this molecule, where the end of each line is really representing a carbon atom. In these representations, hydrogen atoms aren't explicitly drawn, but are implied through the 4-bond rule with carbon. So in this example, there are 5 carbon atoms, and I can number them. I could draw out a Lewis structure representation of this molecule. We have 5 carbons here, so we really have the following Lewis structure. The carbons at the ends get 3 hydrogens, and the central carbons have 2 hydrogens. In addition, we could write a structural formula of this molecule as being CH3, CH2, 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 CH3. This can be simplified as well into its molecular formula of C5H12. To name this compound, the first part of the name will come from the number of carbons in the chain, and the ending of the name will refer to the type of carbon chain we have. In this example, since there are 5 carbons, we use the pent prefix, which you might remember from naming inorganic compounds. The end of the name is ane, since there are only single bonds. Therefore, this molecule is pentane. This molecule is what we call a branch molecule, where we have some additional branches that come off the main carbon chain that we will have to add to the name. First, we can see that there are only single bonds present, so again we have an alkane, and the end of the name will be ane. I need to now determine the longest chain of carbons, where numbering can really help in these examples. When numbering, it's useful to recognize that I'm looking for the longest chain. Sometimes these can be tricky based on the way they are drawn, so take your time and count your carbons. If you start numbering your molecule closest to the end of the molecule that contains the most branches on the left side here, you'll result in a properly numbered chain. I have a total of 7 carbons, giving me the root name heptane. However, you can see here that I have additional carbons that I need to describe in the name. I need to first explain where the branch is attached to the main chain. You can see that it's coming off the 3rd carbon on the chain, so I have to have the number 3 and a dash after it. I then need to describe what the branch is. Since this branch contains 1 carbon, it is the same as you would name an alkane, but instead of putting ane at the end, you put YL. So this would be meth, meaning 1, and then YL, or methyl. So this would be 3-methyl-heptane. Let's look at a more complicated example. First of all, we're looking at a ring structure here. So the root name comes from the number of carbons in the ring. The root name is pentane, but we put cyclo in front to indicate that there are 5 carbons in a ring. Next, I like to name the branches that are coming off this ring. I have an amino here, as well as a 2-carbon chain, which is called ethyl. And then a chloro substituent. Now the locations of the branches or substituents needs to be determined, where we can again keep the numbers as small as possible. In this example, it makes sense to start numbering with the substituent that comes first alphabetically, so 1 amino, 2 ethyl, and 3 chloro. To put this whole name together, we just need to put the substituent names in alphabetical order. So 1 amino, 3 chloro, 2 ethyl, cyclopentane. Now let's draw a line structure from a name. There are many ways to approach these types of examples, but I do it in the same way as starting to name the molecule. First, the root name here is 1-hexene, which tells me I have 6 carbon chain, and there's a double bond on the first carbon. So I can start by drawing this root structure. Now I have 2 bromo groups coming from the di, and one is coming off the second atom in the chain, and the other is coming off the third atom in the chain. So here is 2,3-dibromo 1-hexene. The Lewis structure can also be drawn here. This can sometimes be helpful if you need to determine the structural formula. This can eventually help you determine the molecular formula. I hope you found this video helpful, and thank you for watching.